strangest of the ancient mysteries is the five-element theory of the universe. In this, there are four earthly elements: earth, water, fire, and air. And there's the fifth, a celestial element, that element which God used to construct the universe itself. Now, 2,500 years ago, this theory had spread across the known world, from ancient Greece, India, Tibet, China, Japan, from Buddha to Aristotle. And yet it could even be much older than these civilizations, because no one knows where it came from and no one knows where it started. Now, curiously, physics also has four principal elements, which they used to describe the universe. These are known as SI units. And so we could ask, could there be a fifth element which links these four elements of physics together and so unifies our universe? And in the process show that our universe is such because it could not be otherwise. In this particular video, we're going to use these four elements to find a potential fifth element and show how this element can then be used to solve the fundamental constants of physics, something that modern physics itself still cannot do.
The four classical elements are typically known as earth, water, fire, and air, although their counterparts can also be found in Eastern mysticism. Now, physics also has four principal elements. These are called SI units, and they are mass, length, time, and charge. Now, the elements of physics, the speed of light, the charge of an electron, and so forth, have been measured experimentally to an extremely high degree of precision. Consequently, we can extrapolate from these data and look for an element which is common to all of them, a sort of analogue to the ancient fifth element. And what we find is an actual candidate for a fifth element. It is the square root of Planck momentum. So what I've done here is rewrite Planck momentum with a square root solution, which I've labeled Q. Now, it's quite simple. But from here, I've made a hypothetical Planck ampere using Q, speed of light c, and the fine structure constant alpha. As you can see, it's quite a simple geometry, merely the volume of velocity over the volume of momentum. These are the mass constants. I've merely rewritten them in Planck units, but using Planck momentum instead of Planck mass. Otherwise, they're fairly standard formulas. What is more interesting are the charge formulas. From the ampere and from Planck time, I can make a formula for elementary charge. I then use this formula, or Ampere's law, to make a formula for the vacuum of permeability. And from this formula, we can make the rest. Now, here is a formula for the electron as a magnetic monopole. I discussed this more in the video of the electron, but I note it here because it can be used to solve the Rydberg constant, and this is very important. Now, the formula for this vacuum permeability includes Planck length. So what we can do is rearrange this formula to solve Planck length in terms of Q, alpha, and the speed of light. When we do this, we can then change all of our formulas by removing Planck length, and so all formulas now can be solved in terms of alpha, Q, and C. We can even do this with the Rydberg constant, because the Rydberg constant comes from our formula for the electron. And so C has an exact value. The Rydberg constant we know precisely to 12 digits, and alpha we know to 10 digits. So this means that we can now solve all the formulas in terms of alpha, C, and the Rydberg constant. And so the minimum precision we have for all formulas is now 10 digits. Now alpha has the lowest precision, so what we can do is test this using an online calculator. And on this online calculator, we input a value for alpha. The default value is the co-data value. Now these are the solved values, and these are the co-data equivalents. And as you can see, we have precision for all. All our values are within experimental precision. Likewise, you can input your favorite value for alpha and then see what happens to our constants. When we study these formulas, their structure, we find that they offer a completely different view of our universe. A view that can solve gravity without gravity, atoms without an electric force. A universe that is without mass or energy or forces or any physical or material substance. A universe whose dimensions are the dimensions of motion, momentum, velocity and time. René Descartes was famous for the quote, "I think, therefore I am." We could also declare, "We move, therefore we are." In the next video, we use the matrix to find a solution for the electron and end up with a mathematical universe hypothesis.